Math 3, practice 1.1.2. So we're dealing with the bell curves, z-scores now, and standard deviation. So let's take a look at the first two. So the mean score on the verbal section of a particular state's high school exit exam in 2011 was 497, and the standard deviation was 114. Nafani scored a 620 on the test. Assume the scores are normally distributed. So what's the z-score? Alright, now remember with z-scores, okay, the way we find the z-score is this with this formula right here, where x stands for our data point, okay, in this case, so we've got z equals x minus mu over sigma. So he scored a 620, that's our data point. So we go z equals 620, okay, minus, then we have the mean, right? Looking back here, mu is the mean, and sigma is the standard deviation, okay? So the mean was 497, the standard deviation was 114. So we type that into our calculators. I mean, you could do it by hand, but we want that decimal actually for the next part. So divide that by 114 and we end up with a z-score of 1.078947368. However, as we read over here, okay, we want to usually round it to the nearest hundredth, okay? And then we can use that for question number 2 is going to ask us for one of these, okay? So back here, so the nearest hundredth would be right there, so we'd round up to 1.08 would be our z-score. So we got that answer. Now, what percent of students who took the test in 2011 scored lower than Nafani? So lower, we want on that bell curve to have the percentile. So where do they fit over here? You know, how much shaded in do we go? Okay, that's what we're essentially looking at. Okay, so that 1.08, the way we do that is we need that, sorry about that bell, so we need that z-score table. So we look up 1.08. So it's positive, so we're on the positive side. So this first part, that's the 1.0. And then the second part would be the 0.08. Okay? So we look down to 1.0, okay, which would be right here. Then then the 0.08. And so we go down to where they meet. And we get 0.8599, which is basically 86%. So that tells us that 86% of the students scored lower than Nafani. Now, here's the cool thing to realize here. Okay. Apparently, it's not a good idea to do this when there's a lunch ending. Okay, so the neat thing I was going to say is, okay, we dealt with standard deviations, right? One standard deviation away we said was 68%, 2 was 95, and 3 was 99.5. And then we also did the separate ones, right? We had like 0.15, 2.35, 13.5, 34%, 34%, and so on. Notice what happens, that's kind of like the standard deviation. So 1.08 would be slightly past one standard deviation to the right, which if we added all those up, that should be pretty close to that 86, because it's all connected that way. It's all dealing with that area, that percent under the curve. Yeah, that ends up being 84. So had he had a z-score of 1, we would have had an 84 there, right? 1.00. Let's check that out, 1.00. Look at that, 84 0.84, 84%. So those percents here are tied with the z-scores, okay? And if it's a positive z-score, we go to the right, 1 standard deviation, 2, 3. So those numbers you get, if they're positive, is how far to the right it's going to be. If they're negative, it's how far to the left. So it's all connected like that, which I just thought was an interesting little tidbit you'd like to know. So let's jump on to the next question. Okay, factory produces plastic cell phone cases. To fit properly, each case must have a width between 53.5 and 54.5 millimeters. The quality control manager for the factory collects a random sample of 100 cases and determines that the widths are normally distributed, with a mean width of 54.2 and a standard deviation of 0.3 millimeters. So what percent of cell phone cases meet manufacturing specifications? So if we think about that bell curve, okay, we had a mean of 54.2, standard deviation of 0.3. So if we go to the right, that would be 54.5, right, once. The second one would be 54.8, and then 3 standard deviations would be 55.1. If we go to the left, down 0.3, it would be 53.9, then 53.6, and then 3 standard deviations, 53.3. So we have 53.5, okay, so that would be slightly below here, wouldn't it? And then 54.5, which would be right on line there, right? Okay, so we want to know this area in between, what percent is that? Okay, well, we could estimate 34 and 34 and 13.6, or 13.5, right? So it's probably going to be close to like 81.5%. Okay, but the way we can find it is if we find what this percentile is, okay, which is the whole thing, and we subtract what this percentile is, finding their z-scores, that's going to be the easiest way to figure it out. Okay, though since the one is 54.5, I mean we could find that easily doing the 0.15, 2.35, and 13.5. Which if we did that, we'd get 84% for that whole red one. So then we just have to find this one and subtract it. So I'll do it both ways, okay? So to find the z-score, remember we have that formula, which is, I'm kind of running out of space, aren't I? Z equals R's, which was, we'll do 53.5 first, minus our mean, 54.2, over our standard deviation, 0.3. So using the calculator, 53.5 minus 54.2, divide that by 0.3, we get negative 2.33, okay, when we round. So we go to our z-score table, it's negative here, it was negative 2.33. So I go down to negative 2.3 right here, and we go to and then we go to 0.03 right here. So we end up with 0.0099, so 0.01, so 1%. Is below that. Okay, so making sure I type things in correctly. Yeah, so 1% would be it's less than that one. Okay, now if we do the 54 one, so we'd go 54.5 minus 54.2 over 0.3. That gives us exactly 1, which is what we were thinking, right? And what do we do when we go to exactly 1? On the positive, it's 84%. Okay, so we have 84%. So then we're going to take this one and subtract that one, and we end up with 83%, which was, we were slightly off, right? But we were pretty close with our guess, 81.5. That was a decent guess, but because that wasn't exactly on there, That's why. So that one was 83%. Okay. Now it says suppose the production line is adjusted so that the mean width is decreased to 54 millimeters and standard deviation remains the same. What percent of cell phone cases will meet manufacturing specifications? So it's the same idea, we've just changed this number. So we go 53, we got to find the z-scores, 53.5 minus 54 over 0.3. And then we find the other z-score, which is 54.5 minus 54 over 0.3. Okay? So we already found, well, we've got to recalculate 53.5 minus 54 divided by 0.3. Gives us negative 1.67 when we round. 54.5 minus 54 divided by 0.3 gives us positive 1.67. Okay. So looking those up, positive 1.67, I go to 1.6, which is right down here, and then 07, which would be right here, and we find that that's 95.25, so 95%. Okay? So that would be 95%. Then the negative, same thing, negative 1.67, so negative 1.6 is right there, and negative 0.07 is right there, so that would be 0.0475 or 0.05 or 5%. So that would be 5%. So now to find the difference, 95 minus 5 would give us 90%. So a bit higher, right? 90% in would be a bit higher. Okay, which would probably be happier for our specific, our manufacturer, so you have less issues, less customer service problems that you have to deal with. Okay? Alright, now question 5. Suppose that the mean width of the cell phone cases is 54, okay, and management would like 95% of the cases to meet manufacturing specifications. What standard deviation is required? Alright, so now we're trying to go with a z-score. Remember, 95% is negative 2 to positive 2, right? So if we work backwards, and we go positive 2 and negative 2, so positive 2.0, okay, would be 0.9772. Okay, and a negative 2.00, so we go to the other end on this one, would be 0.0228. So this time I'm actually going backwards. We're saying to get 95%, it's going to be this one minus this one, okay, the right side minus the left side, and that has to equal 95%. So looking at those percentages, okay, on these to get the two standard deviations away, we use those numbers to find percentages to find the z-scores, okay, and then from there we should be able to work backwards. So we're basically saying we've got the 53.5 minus 54, but we don't know what the standard deviation needs to be. So that's going to have to be equal to our z-score. So I just kind of set it up separately. So in other words, the idea here is that we know this, we know this, we know this, but we don't know that. So that's what we're looking for. So we're just setting things up differently. Okay? So, and we're going to have to do that for both of them. So my other one's going to be what? 54.5 minus 54 over that, and that would equal the 0.9772. So basically what's going to have to happen is we're going to times by this on both of them, okay, which would we do on the other side, and then we'd end up dividing by this. So really we're just swapping positions. So that would be 0.0228, and that would be what we're looking for, and this one would be our sigma, and that would be 0.9772. So let's type those in. So 53.5 minus 54 is negative 0.5 divided by 0.0228. Gives us negative 21.9. That seems weird. I wonder if we weren't supposed to do that side. Let me try the other one. 54.5 minus 54 divided by 0.9772 gives us 0.51166. Alright. I'm thinking I must have done something wrong here, because these don't look right to me, because that would be a bigger standard deviation. So let's think through this. Okay, so they wanted 95%, which we know is 2 standard deviations away, right? I just figured out what I was doing wrong. Okay, I went with these numbers, and I shouldn't have went with those numbers. Okay, because then they gave us that, and that was wrong. Okay, that wasn't the z-score, that was the percent. So what we needed to do is actually go like this. Okay, 95% is on either side, which means for these two sides that would be 5% of that, because 95 and 5 make 100. So this split in half would be 2.5% and 2.5%. So I would change that out of a percent, so 1, 2. So it would be 0.025, okay? And then I take that, and that's what I look up on the z-score. So I look up for 0.025. And I don't think it's on this one. I think we'll need to look on the negative one. 0.025. So I'm just scouring this. So okay, so we're getting close. 0.0221, 0.023, 0.023, 0.024, 0.025. Okay, see, now we go backwards, and this is our z-score. That's what I did wrong. Do you guys see that? Hopefully you do. So my z-score is really negative 1.96. Okay. So the main idea was right. I just put the wrong number in. So it's my lower bound. So negative, what did we say? Negative 1.96. Okay, that's what we'd put there. And then 53.5 minus 54. Divide that by negative 1.96. And we end up with 0.255. So basically 0.26 would have to be our standard deviation in order for that to be 95%. So my mistake was I used this number on the z-score table wrong. I needed to use this to know what the percentage was on this side, and then I can work backwards to find the z-score. Anyway, so hopefully we learned from our mistake there. Okay, now moving on. The wait times for a table at a particular restaurant are normally distributed. With a mean of 25 minutes, 75% of the parties who dine there wait less than 30 minutes for a table. So what is the standard deviation of wait times at the restaurant? What percent of parties wait for more than 15 minutes? Alright. So this one we've got to slow down and think through this one to make sure we don't make a mistake again. Okay. So they've got a mean of 25 minutes. 75% of the parties who dine there wait less than 30 minutes for a table. So we don't know what the standard deviation is, but 30 minutes would be bigger, right? So we want to know all these people less here. So we need to find, we know that that's 75%, right? Okay, so then we turn that into a decimal, so it would be 0.75 basically, right? So that would be our percent, so we need to go to the z-score table and look up to see what z-score that would be. Then we can fill in our stuff for the information that we have. Okay, that would be 30 minus 25 over the standard deviation. So once we find this, then we can solve for standard deviation, which is what we should have done on that last problem. Okay, so 0.75. So let's look here, 0.75, okay, 0.3, 0.74, 0.75. This one could also be there's basically 3 that could be 0.75, or 4. 4 that could be 0.75 on that. Okay, let's go, I think this one looks the closest. You could do it with other ones, but I'm just going to pick that one because it looks closer than the other ones to me. So it would be 0.68. Okay, because that's where it comes out to. So we'd go 0.68 is our z-score. Oops, too far. So we'd times by sigma, and we'd have 0.68 standard deviation equals 30 minus 25. So we divide by 0.68. So anytime you have the percent and you're finding the z-score to find the standard deviation, essentially it should look like this. Okay, so 30 minus 25 is 5. Divide that by 0.68, and we would get 7.35. We'll just round to the nearest hundredth. Okay, that would be our z-score. You could round up to 7.4 if you wanted to. Alright, so now what percent of the parties wait for more than 15 minutes? So we find the z-score of 15 down here. Okay, so I'd now use the original one, okay, because I know what my standard deviation is. So I'd go 15 minus 25 over 7.35. Find our z-score. And then once we got our z-score, we look up the percent. Much easier that way, huh? So z-score of negative 1.36. So I go to my negatives. Clear the ink here. Negative 1.3 right here. Okay. So along this line. And then 6. So 0.6 going down. So it would be that one right there, right? Which is 0.0869. So 0.07, so 7%. Okay, now that's not our answer. Okay, that's to the left of this. 7%. That's how many people wait less than 15 minutes. So we want to go back the other way. So remember, the whole thing is 100%. So we'd subtract 7 from 100% and come up with 93%. That's the amount of people that have to wait more than 15 minutes. Alright, so a marketing firm examines the ages of patrons who attend the Saturday matinee at a local movie theater. The ages of 40 people are listed below. Assume that the ages of movie patrons at the Saturday matinee are normally distributed. So find the z-score for a 24-year-old patron who attends the matinee. What percent of... Okay, so we need to use this data first and find the standard deviation. Okay, remember that's... You get the mean first. Okay, once we've got the mean, then we subtract it from all these numbers. Then we take those new ones, we square them, find the mean of that, take the square root, and that's how we get our standard deviation. Okay, I'm not going to do all that because I don't have enough time to do it by hand. So I'm going to do that with my calculator or with Excel, and then I will put that information on, and then we'll use that to go from there. Okay. Okay, so the mean was 35.5. Standard deviation I found was basically 7. It was 7.003571, so I'm just putting 7 down. Okay, so then for the z-score we go 35.5 for a 24-year-old, so 24 minus 35.5 divided by 7. That'll get us our z-score. So 24 minus 35.5 divided by 7. That gives us negative 1.64. Okay. Okay, so there's our z-score. Now, 9, what's the percent? What percent of the patrons are older than 24? Remember, finding the percent here will actually be those that are younger than 24. So we are actually going to have to go 100 minus, because that's percent, minus the percent we find to get those that are older. So negative 1.64, so negative 1.6, and then 4 is right down here. So it'd be 0.0505. Okay, so basically 5.1%, I guess. So 100 minus 5.1 would give us 94.9%, or older. Then it says estimate the percent of patrons in the population who are between 40 and 50 years old. So now, once again, on the bell curve, we'll find the 40-year-olds, we'll find the 50-year-olds. The z-score percent will tell us what they all are below. So then we subtract this one from this one to find the middle piece. So I'd go 40 minus 35.5 over 7. Okay, find that z-score, which is 0.64. Okay, then we find the percent. So 0.64, 0.6, 0.04. So right there, which is 0.7389, so round to 74%. Okay. Then we do it for the 50, so 50 minus 35.5 over 7. Okay, find that z-score, which is 2.07. So we go to 2.0, and then 7 is clear down here. So that'd be 0.9808. So basically 98%. Okay, so we get 98%. So then 98 minus 74 would give us what we're looking for, which is 24% in the difference. And there we have it.